Hello, this lesson is lesson 8.1, Solving Systems of Linear Equations, Part 2. On our last video, we talked about solving systems of linear equations using graphing to find a point of intersection. Today, we are going to apply those skills to actual real-world situations, word problems. So join me in just a moment. So today's work is going to be coming from pages 230 through 232, and then your homework is going to be 233 and 234. So this is, again, I said part 2, solving word problems using systems of linear equations. Our standard is EE3. I can find solutions to word problems using a system of 2 linear equations in 2 variables and graphing them to find a point of intersection. So similar to what we did on the first video before this, but this time we're going to, again, like I said, put the word problems in. So systems of equations, just to refresh your memory, is a set of equations that have the same variables and whose solution is an ordered pair that represents meaning in the context of a real-world situation. So we're going to go under the document camera now, and we are going to do some graphing. Okay, this is page 230, example 2, and I just wrote it out here because I'm under the document camera. And these are the kind of problems that you're going to be seeing a lot when you get to algebra in high school, as well as these problems are definitely going to be on the ACT if you're ending up taking that for college entrance exams. So definitely something you're going to want to know how to do. So let's read the problem. There's a lot of information in here, but I'm going to break it down for you. Keisha and her friends visit the concession stand at a football game. The stand charges $2 for a hot dog and $1 for a drink. The friends buy a total of 8 items for $11. Tell how many hot dogs and how many drinks they bought. Okay, so I'm going to start by underlining important information. And like I've said many times, most of the information they give you in a word problem number-wise is something that you're going to be using in your calculations. So the stand charges $2 for a hot dog and $1 for a drink. The friends buy a total of 8 items for $11. And then I'm going to circle what we need to find out. So we need to know how many hot dogs and how many drinks they bought. So let's see how we could write a systems of linear equations so that we can solve this. Okay, so I'm going to, first of all, decide what my variables are going to be. We're going to need 2 variables. So we're going to let x equal, and you can pick variables that represent what you're talking about. I'm just going to use x and y right now because your book example uses x and y, and I don't want to confuse you. So let x equal the number of hot dogs, and let y equal, what do you think? Exactly, the number of drinks. Now we have to come up with not 1, but 2 equations. In all your previous units, you've only had to come up with 1 equation. Well, actually, in the last unit, you've had to come up with 2 equations and set them equal to each other. This is slightly different. You're not setting them equal to each other. You're trying to find the point of intersection. So we got to come up with our 2 equations. So our first equation, we're going to call equation 1. Let me see if I can slide this up a little bit. Equation 1, that's going to be the number of items equation. And we can figure that out because we know that x is the number of hot dogs plus y is the number of drinks. And we know all together, we go back up to our word problem, we know all together that they bought a total of 8 items. So we know that number of hot dogs plus number of drinks is going to equal 8. Now we need to come up with another equation. So equation 2, move this way up, equation 2 is going to represent cost. Okay, so equation 1 represented number of items. Equation 2 is going to represent the cost. So it tells us, if we go back up to the word problem, it tells us it charges $2 for a hot dog and $1 for a drink. And then it also gives us the total cost of $11. So let's go move down again. So we can set it up as the number of hot dogs bought times the cost of those hot dogs. So if I bought one hot dog, I'm going to pay $2. If I bought 2 hot dogs, I'm going to pay $4. If I bought 3 hot dogs, I'm going to pay $6. You can see that the number of hot dogs is multiplied by $2. And if you want to go ahead and put a $sign in there to keep track of what that number represents, feel free to do that. Plus, now we need the cost of the drinks. Well, that word problem told us they were $1 times the number of drinks, right? So technically, we could drop the 1 in our equation because any number times 1 is just the number, but we're going to leave it in there just for clarity. And then we know together the total cost they spent was $11. So that's going to go over here. So you're going to have to keep track when you're doing these that one of them is going to represent items of some sort, and one of them is going to represent some kind of cost or value or something to that effect. It may not always be dollars, but it'll be something to that effect that needs to be multiplied by the number of items in some way. So now we have our system of equations. We have our 2 equations for that. So let's rewrite those onto the side here. We have x plus y equals 8. And we have 2x plus, we're just going to say 1y equals 11. And we're going to put our little bracket, meaning this is a system of equations. Okay, now how are we going to solve that system of equations? Well, we're going to want to find the point of intersection so that we can solve our word problem. So now we're going to graph, because I haven't taught you any other ways at this point mathematically how to find that point of intersection. So we are going to graph these now. Okay, so here is our graph, and I got some wider graph paper. I think it'll be easier to see. So this is our system of equations that we just came up with from our word problem. And then if I look, I kind of moved it down because I'm going to need a little bit more numbers going up than I do down. So it's not exactly in the center, but it doesn't need to be. You can adapt it to how you need it to be. So in order to graph these 2 equations, I'm going to slide down for just a minute before I graph them. So in order to graph them, x plus y equals 8 and 2x plus 1y equals 11, I have to get them into a certain format. Right now they are currently in standard form. So this is them in standard form. And that, again, from the last video, if you remember, was in the form ax plus by equals c. So they are in the form of a number in front of the x. In our case, we just didn't put the 1 in front of there. Plus the by, the number in front of the y, equals a constant. That's the standard form. The slope-intercept form is the form we need to graph. Slope-intercept form. That's the one you're familiar with, the y on one side and the rest of the equation on the other side. So we have to do a little manipulation. We have to get y by itself over here. So let me pick a different color. Maybe this color. So we have x plus y equals 8. And I hope you can see that color okay. We want to move everything else except the y over to this side. And we only have one other thing to move over, so that's good. Not too much to do. So how do I move the x over to the other side? Exactly, I subtract an x from both sides, minus x. And x minus an x is going to cross us off, becomes 0. And I'm left with just y equals, and I can't subtract an 8 and an x, so I'm just going to rewrite it as 8 minus x going horizontally. But that's still not in my slope-intercept form. Because notice how slope-intercept form is normally in this form. Y equals mx plus b. So we have the b first and the mx second. So we just have to switch that around to y equals, don't forget this is a negative, negative x plus 8. I just switched it around. So this negative is really the slope, which is really -1, right? Okay, so that's the first equation. The second equation I also have to manipulate. I can graph this now that I have that in that format, and we'll graph that in just a moment. Let's look at the second one. We have to get the y by itself. There's a little bit more to do in this one, not too much. So I'm going to, first of all, subtract 2x from both sides. See, I don't run out of paper here. That will cross these off. They will become 0. And I'm left with just 1y or y. I'm going to just drop that 1 now. And then I have 11 minus 2x. I'm just rewriting it horizontally because I can't really subtract those numbers. You can't subtract a variable number from a constant number. And now I notice, well, actually that's all I have to do except rearrange now. I have to get it into this y equals mx plus b format, and currently I have it in b and then mx. So I'm going to rearrange it. Y equals, don't forget that's a negative, negative 2x plus 11. So now I have both of these into the right format to graph them. So we are going to go back up and graph. So let's graph that one. Y equals negative x plus 8. I don't think there's any way to keep that on the screen, but I can rewrite it up here in slope-intercept form. Is really y equals negative x plus 8. I'm just going to rewrite it so you can see it. And then the other one turned out to be y equals negative 2x plus 11. So you can see, let me get this board out of the way, you can see that's the slope-intercept form, from standard form to slope-intercept form. So now we're going to graph them. So let's graph y equals negative x plus 8. This should be coming second nature to you by now on how to do this. The y-intercept is 8. So that's where x equals 0 and y equals 8. So if I go up, this is where x is 0. Here's where it crosses y equals 8. And then I have a slope, which is the number in front of x. In our case, it's a negative 1 over 1. It's going to be a negative 1 over 1. Kind of keep that in mind. So negative 1 means I'm going to go down 1 from my y-intercept, and I'm going to go to the right 1. So this is my second point, and I can draw my line. And again, accuracy is important when you're graphing this. I'm trying to see. Hopefully we'll have this. That's why next session I'm going to teach you the mathematical way to know for sure that you're getting the exact point of intersection. Because graphing can sometimes be a little bit off. So I'm going to label what this is. This is y equals negative x plus 8. If I want to rewrite it as this way, it's x plus y equals 8. That's the standard form. Same equation, just written different ways. The second equation that I want to graph then is y equals negative 2x plus 11. So I start with my y-intercept, which is 11. So I'm going to go all the way up on the 0 line and on the y-axis to where I hit 11. And then my slope is the number in front of the x. That's my m. So that's negative 2. It's the same as negative 2 over 1, right? You always can put a number over 1 when we need to have a rise and a run. So my negative 2 means I'm going down 2 and I'm going to the right 1. So down 2 to the right 1. So that will become my graph. Remember, you just need 2 points to make a graph. And I don't know if this is going to be accurate like I want it to be, but let's just see what happens. May not be exact. I'm hoping that it comes out exact, but we'll see. So now we're going to call that, let's put our, that's y equals negative 2x plus 11. Or if we want to write it in standard form, it's 2x plus 1y equals 11. Same thing, written differently. So now our solution to our word problem, again, what was our word problem wanting us to do? Let's go look at that for a second. How many hot dogs and how many drinks that they bought? That's what we're trying to figure out. So that's going to be our point of intersection, which I did a pretty good job. It's actually right here. That's our point of intersection. What are the coordinates of that point? The coordinates of that point are, well, let's go down. Oops. Let's go down. 3, 5. That's my dog again. All day long. Bark, bark, bark. Okay. 3, 5 is my point of intersection. So that's this point. If I can somehow, there we go. Put a little arrow by it. So that is going to be the solution to my word problem. So we know it's 3y, so let's go back to the word problem. Take a look at this. We know that 3, 5 is the solution right here. 3, 5. Now, what does that mean in context of the word problem? Because we still have to finish that off, right? So we know that 3 is my x value. 5 is my y value, and we know what x and y equal because we defined it when we began our word problem. So x was the number of hot dogs. So we can say the answer is, move it up just a little bit. I can put this in here. We can say the answer is there are, or they bought 3 hot dogs. And how many drinks did they buy? Exactly. They bought 5 drinks. Now we can check that, and we should check it. So let's check it. How would we do that? How do we check? So I'm going to bring this up so we can still keep that there so we can see it. We have our answer. Let's circle that nice and big. Answer to our word problem is that, right? Now let's check it. So I'm going to use green to check it. Check. I don't think I like that brown. I think it's too light. Okay, so let's check it. We have our 2 equations. Let's go back up and see our equations. X plus y equals 8. And 2x plus 1y equals 11. So let's check by putting in 3 and 5 for the x and the y values. Remember we said our solution was 3 and 5. So we have bought 3 hot dogs plus 5 drinks, and that should be true that it equals 8. Is that true? Exactly. So this is a true statement. So far so good. Both statements need to be true in order for us to know we got the right answer. So now we're going to plug 3, 5 in for x and y here. So 2 times 3 plus 1 times 5 equals 11. Now let's see if that comes out to be true. 2 times 3 is 6. Always do multiplying before adding. Plus 1 times 5 is 5 equals 11. So does 6 plus 5 equal 11? Yes, it does. So it's a true statement. So that was the solution. We did it correctly. That's how we know. Okay, the next one I want to do is your guided practice number 3, which is the page one of the pages you're going to turn in. So I usually do all the guided practice problems or most of them for you on the videos, so that helps you. So this is number 3. So I wrote it out. Mrs. Morales wrote a test with 15 questions covering spelling and vocabulary. Spelling questions, which is labeled X, are worth 5 points, and vocabulary questions Y are worth 10 points. The maximum number of points possible on the test is 100. So again, we're going to start by underlining all these important numbers. And they're telling us what X and Y are to represent. So the spelling questions are worth 5 points. The vocabulary questions are worth 10 points. The maximum number of points possible is 100. And there's another part right up here. There's 15 questions on the test, combined with spelling and vocabulary. So our first step is going to be to write equations after we decide what X and Y represent, which they're telling us. So let X equal and let Y equal. We need to know that. Super important. They've already told us. X represents, go back to the word problem. Yes, number of spelling questions. Remember how I told you the first equation is always something to do with number of items? So this is going to be equation 1 when we get going. Y represents number of vocabulary questions. Okay, important to know what we're talking about. So now we're going to write our 2 equations. And on the previous one, we had hot dogs and drinks. This time we have questions from a test. So equation 1, equation 1 is going to be something to do with number of items. In our case, it's going to be number of questions. So let's see what we can do as far as putting together an equation. Now, in your book, it tells you they want it in slope-intercept form. So we're going to start by putting it in standard form, which is easier to do, understanding like in your mind. It's easier to understand that way first and then to manipulate it. So number of items, well, we know that the number of spelling questions plus the number of vocabulary questions, what does that equal? Somewhere in the word problem. Exactly, you can just see it. 15 questions total, right? So there was 15 questions. They were divided between spelling and vocabulary, and altogether there were 15. So there's our equation number 1. Equation number 2 always has to do with, what did I say? Some kind of cost or value. I'm going to add the word value because in our case, this question isn't dealing with cost, but it's dealing with value. We go back up here for a minute. What is the value we're talking about? The spelling questions are worth 5 points. The vocabulary questions are worth 10 points. So that'll help us make our value thing. So let's say there are there's this number, there's X number of spelling questions times 5 points per question, right? Plus there are Y amount of vocabulary questions, and they're worth 10 points each. And all together, let's go back up to the word problem. What number haven't we used yet? How many points is possible on the test, or are possible? 100, exactly. So all together, there's 100 points. So if I got all my spelling questions and all my vocabulary questions right on the test, I would get 100 points. So that's our system of equations. Oops. I'm going to write that down here. Our system of equations is x plus y equals 15 and 5x plus 10y equals 100. But I can't leave it in that format because the only method you know to solve these so far is graphing. So we have to get our standard equations into slope-intercept form. To do that, I'm going to have to manipulate these 2 equations. So I'll just use, I don't want to use that brown. I don't think that was very seeable. Let's try blue, light blue. So we have x plus y, that's better I think, equals 15. And we want to get y on one side because we need it in the format of y equals mx plus b. So we got to get y by itself. To do that, we're going to subtract x from both sides. The two x's will cross off because they will become a 0, and we'll be left with y equals 15 minus x. Rearrange it so we're in mx is first and then b is second. Y is equal to negative x plus 15. Okay, so that is our system of equations for the first one written. We're going to rewrite it that way. Y equals negative x plus 15. And we know that the number in front of the x is a negative 1 over 1. The second one we have to manipulate as well. So that one, I'm going to come over here a little bit, is 5x plus 10y equals 100. We have to get the y by itself. So this one will be a little bit one extra step. The last one didn't have that 10 and had a 1 in front, so we were good. This time we're going to subtract 5x from both sides. So if I do that, 5 minus the 5x is going to cross off, and I'll be left with 10y equals 100 minus 5x. So I'm going to go ahead and reverse that and write that in the right format. 10y is equal to negative 5x plus 100. I just switched it around so the x comes first. I'm not quite done on this one, however. Move it up a little bit. I got to get rid of this 10. So this is meaning multiply 10 times the number, right? So the inverse of multiplying, exactly, dividing. So I'm going to divide by 10. However, I can't just divide by 10 on one side. I have to divide by 10 on the other side. But I have a problem now because I have two numbers on that side. Before, when I've ever done these, I've only had one number by this time. So I have to divide each part of the expression by 10. I can't just divide one part by the expression or by 10. So now I'm going to cross the 10s off because 10 divided by 10 is 1. That will leave me with y equals, now I'm going to reduce this. This is negative 5/10. If I reduce 5/10 or negative 5/10, what will I get? Exactly, oops, wrong color. I will get negative 1/2 x. 1. And then if I divide 100 by 10, what do I get? Right, 10 times 10 is 100. Now I have that in slope-intercept form. So now I'm going to rewrite that for our system here as y equals negative 1/2 x plus 10. So now I'm able to graph it. I have it in my slope-intercept form, and I'm ready to go. So our next step then is to graph this. Now, what did your problem say? Letter A said, write an equation in slope-intercept form to represent the number of questions on the test. So this is your part A in your guided practice page. Question B said, write an equation in slope-intercept form to represent the total number of points on the test. This is your part B, guided practice question number 3. And now C is telling us to graph, which is where we're at. So that's what we're going to do next. Okay, here we are ready to graph this. And if you notice, I have put the line, the x, way down here because I need to start my y-intercept up here at 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And again, these numbers are going to be 1, 2, 3, 4, 5, etc. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 1, negative 2, negative 3, etc. So my first one, this is in standard form that we rearranged to get into slope-intercept form. So we have 15 as our y-intercept. Put our dot right there. And our slope is -1/1. Down 1 to the right 1. Down 1 to the right 1. And hopefully, again, we'll get our graph and our line straight. That's why a ruler is really helpful during this time, that you're using graphing to find the intersection point. Okay. And the second one is 10. Well, let's label this first. This is y equals -x plus 15, or x plus y equals 15. Same thing. And the green one will be our other line. 10 is our intersection point. -1/2, that's down 1 to the right 2, down 1 to the right 2. And I don't know how we're going to see this point of intersection here. I wonder if I need to. Yeah, it's going to actually run off the graph is what's going to happen. So I'm going to have to put another piece of graph paper next to that one so that we can see where that point of intersection is. Now that I made the bigger grid squares, I run out of space easier. So let's move this over. Let's see if we can do this like this. So let me just fold this over so that we have a graph next to a graph, okay? And I'm going to do this like that. Wish I had a piece of tape that I could, yep, I do, okay. So that I can tape this down so it stays, okay? All right, so let's extend our line a little further. Extend the whole thing here, actually. Keep going. Like that. So now we can keep adding numbers. 6, 7, 8, 9, 10, 11, 12, etc. So now let's extend this line that we started a little bit further. You can see it, okay? Back up. As good as I can get, I think. And then the other line has to also extend like this. Get it exactly right, or close to exactly right as I can. Now we can see our point of intersection a little bit off of what it should be. Should have intersected over here. What did I do wrong here? Maybe my line should have went more like this. Probably should have. Let's try that. Right here is how I should have probably done it. So let's draw my line like this. That's why I'll be glad when we can do the mathematical way of finding the solution, because this graphing way is not always accurate. So I was trying to white this out. I don't want you to get confused what line is what here. So trying to white that out. Give me the benefit of the doubt here that it's whited out, sort of. Okay, so that's sort of whited out. The line you want to use is mainly there. Okay, so now our point of intersection, the green one's okay, I think. Our point of intersection then is, well, it actually is supposed to be right here. That's supposed to be our point of intersection if I was completely accurate. So that point is point 10, 5. 10, 5. Okay? So now we can answer our question. So if I go back, the question was, did it have a question? Oh, it's part D. It says, use your graph to tell how many of each question type are on the test. Okay, use our graph. So we know that X, we'll put this back, X equals the number of spelling questions and Y equals the number of vocabulary questions. So X is 10, Y is 5. So we can say that the answer then is, move some stuff around so I can see this. Got the pencil holder in my way here. Okay, so let's say, so the answer is there were, go back up, 10, what does X represent? Spelling questions. There were 10 spelling questions, and there were how many vocabulary? Right, 5. 5 vocab questions, right? Now we just want to make sure we did it right, so we want to check, especially when we're graphing, because here my graph was off. I know the answer ahead of time, but if I hadn't, I wouldn't have known that my intersection point had to be a little bit up. So now let's just do the check. I'm going to grab a piece of paper here to do the check. So our check is 10, 5. So we have X plus Y equals 15. This is our check. And don't worry, I know these problems take a long time. I'm not giving you very many to do for your homework, I don't believe. No, I'm not. And then the other one was 5X plus 10Y equals 100. Okay, so I'm going to plug in my point, which was, what was my point? 10, 5. And try that out, check it out, make sure it works. So I'm going to plug 10 in for X and 5 in for Y and see if I get a true solution. 10 plus 5, oops, equals 15. Is that true? Yes, 15 equals 15 is a true statement. They both have to be true in order for our check to work. So I'm going to plug 10 in for X and 5 in for Y. So I get 5 times 10 plus 10 times 5 should equal 100. Do the multiplying before the adding. Order of operations. 5 times 10 is 50. Plus 10 times 5 is 50. Equals 100. Does 50 plus 50 equal 100? Yes, 100 equals 100. We have a true statement. So that point of intersection is true for both statements in our system of equations. So we know that we have done that problem correctly. Okay, now we're coming to the end of our lesson for today. Your homework is going to be to finish page 232, the guided practice problems. I believe I did those with you in the last video, and then I just did number 3 with you on this video. The only one you might have to do is number 1, number 2. So not sure, but double check that. And then you have to do pages 233 through 234. Just questions 5, 6, 7, 8, and 9. They're long questions. They take you a little bit of time, so I don't want to give you too many. And then you're always welcome to try the hot problems. A lot of you are doing those higher order thinking problems, which is great. And I've decided I'll give 2 extra credit points if you want to try those. You don't have to get them right, but you have to show that you tried them. Those are optional. Don't feel like you have to do them. But if you want to, I'll leave that up to you. So that is the end, and I will see you next time. Bye.